In this question, we're told the line L has equation r is equal to 13 minus 3 minus 8 plus t multiplied by minus 5, 3, 4. We're told the point P has position vector minus 7, 2, 7. The point P dashed is the reflection of P in L. In part A, we're asked to find the position vector of P dashed. So here's P and here's P dashed, and here is our line L. I'm going to run a line from P to P dashed. So if we do that, what we're going to have, and let's just put that on, we'll have something looking like so. What I'm going to do is define a point on this line. And this point we could call anything. I'm just going to call it now X. If we consider now the perpendicular bisector of P and PQ, we can now make that the line L. So what I'm looking for then now is the dot product of PX and the direction vector of the line here to be equal to 0. We can go ahead and solve now for t, sub it in and find x. Once I've found x, I can find p dashed from there. So let's go ahead and do that. So what we're going to do then is define this point x. X is going to have the position vector, and I'll write it just here. X will have, and it's just a general point on this line, so we're going to have 13 minus 5t, and then we're going to have minus 3 plus 3t, and then we'll have minus 8 plus 4t. So what I want to do now is dot px. So I'm going to have px dotted now with this direction vector. That's going to give me minus 5, 3 and 4, and this will be equal to 0 if perpendicular. So once I get a value for t, I can locate this point and now go ahead and find p dash from there. So let's look at px. If we consider px, px is going to be x minus p. So if I just write this out now, we've got x minus p. So x is my general point on the line, and then we've got now p just here. So writing this out, that's going to be 13 minus 7, which is going to be 20 minus 5t. I've then got now minus 3 minus 2, which is going to give me minus 5, and then I've got plus 3t. And then I've got minus 8, and then I've got minus 7, so that's going to give me minus 15 plus 4t. So this now is px, so we can go ahead and dot that. So we can say now 20 minus 5t, we got minus 5 plus 3t, then we got minus 15 plus 4t, dotted now with the direction vector, which is going to be the minus 5, 3, 4, will be equal to 0. So let's go ahead and find our value of t. So that's going to give me minus 100 plus 25t, dotting now the j components, we're going to have minus 15, and then we're going to have plus 9t, and then the k components, minus 60 plus 16t, and that will all be equal to 0. So what have we got? 175, so we've got minus 175 plus, and we got 25, 9 and 16, that's going to give me 50. So minus 175 plus 50t is equal to 0. So we can say 50t is equal to 175. And all I'm going to do now is divide both sides by 50. Remember, these questions are non-calculator. So I've got 175 over 50, which is going to give me 7 over 2. So 7 over 2 or 3.5. And let's just write that there. So that's the value of t. So let's go ahead and sub that in. So if I do that now, and I'll write it just here, we can put that in. So we're going to have x. So I've got now 13 minus 5 lots of the value of t. So let's go ahead and work with fractions. Of course, you can work with decimals if you like. So we're going to have now the following. We're going to have 13 minus 5 lots, and this is going to give me 7 over 2. So we have now 26 over 2 minus 35 over 2. So that's going to give me minus 9 over 2. So let's go ahead and put that in, minus 9 over 2 or minus 4.5. Entirely up to you on this one. If we look at the next one, let's go ahead and do the next one. We've got on here now the minus 3 plus 3t. So let's write that now as minus, and I'll write this as minus 6 over 2 plus now 3 lots of 7 over 2. So that's going to give me there 21 over 2 minus 6 over 2, which is going to give me now positive 15 over 2. So let's write that there. That's 15 over 2 or 7.5. Okay, let's now look at the k components. So we've got now minus 8 plus 4t. So 4 lots of 7 over 2. So that's going to give me now the 7, the 4 and the 2 will cancel. So that's going to give me now, on here, we're going to have minus 8, and then we're going to have plus, what's that going to give me? That's going to give me 14. So that's going to give me now 6. So we end up now with 6 in here. Let's just write that in, 6. So as you can see with these questions, often it's a case of just keeping on top of the basic number work, and we've now defined this point. So we've got this point, and that is x. So let's just go ahead and draw this on. So we've got p, and p, we've got now minus 7, so let's put that on. That is going to be minus 7. We've got 2, we've got 7. We've now got x, which we found here to be minus 4.5, so let's write this in. So minus 4.5. We've got now the 7.5, and we got 6. So 7.5, and then we got the 6. So at this stage, you can set up a line, or you consider now simply multiplying this vector here by 2 and going. An alternative way is to say to myself, what have I done to get from minus 7 to minus 4.5? Well, I've added 2.5. So if I consider now adding another 2.5, then we will get to this point. So ideally show this now as a multiple of 2 on this vector between the two, or you can just go ahead and think to yourself. In terms of the marks you'll be allocated, it's better form to give it as an actual line. So let's go ahead, minus 7, so that's going to give me now, I need to take now another 2.5 off this, so that's going to give me minus 2. What have I done here? Well, I've added 5.5, so I'm going to add another 5.5, and that's going to give me 13. What have I done here? I've gone down 1, so I need to go down another 1. So there we go, that's p dash. So we found now the position vector of p dashed, and we can write it in column form as minus 2, 13, 5, or if you like, you can write it as minus 2i plus 13j plus 5k. So that's one way to consider that. Okay, we now need to show that the point A with position vector minus 7, 9, 8 lies on L. So here is L, and we can simply go ahead now and set this up. So what we've got then is the following. We've got minus 7, and then we've got 9, and we've got 8, and this is going to be equal now to the following. We're going to have over here, we're going to have 13, so we've got 13 minus 5t, and then we've got now on the j components, we got minus 3 plus 3t, and then we got minus 8 plus 4t. So all I'm going to do now is solve for either the I, the j, k components, and show now that that holds for the others. So if we consider now on the k components, I'll just write it here, we're going to have now 16 will be equal to 40. All I've done is added now the 8 to both sides. Therefore, we can say that t will be equal to 4. So all we need to do now is check. So subbing it in, we can write now for the I components, we're going to have now minus 7 is equal to 13 minus 5 lots of 4. So does that work? Well, that's going to give me now 20. 13 minus 20 is going to give me minus 7. If we consider now the j components, we've got here 9 is equal to minus 3 plus, now let's just write that out. When you're doing these, quite clearly you're going to have more space to write it in. I'm kind of trying to work around a short or a small amount of space. Do show full workings on what you're doing. Plus 3 lots now of 4, and that's going to give me 9 is equal now to minus 3 plus 12, so it holds. So we can see the value of t holds for each of these, so we can say that it is on the line. So do write that out down here somewhere nice and neat. So let's go ahead and put that on. So what we've got then is now A. A has got the position vector minus 7, we've got 9, and we've got 8. We're asked now in part C to show that angle PAP' is 120 degrees. Okay, let's go ahead and consider this. What I'm going to look at now are these two vectors. I'm going to look at AP and then AP'. So if we consider now AP, AP is going to be equal to P minus A. So if I do that, minus 7 minus minus 7 is going to give me 0. 2 minus 9 is going to give me minus 7, and then we can have 7 minus 8, which is going to give me minus 1. If we now consider A, P dashed, we're going to do now P dash minus A. So I'm going to have minus 2 minus minus 7, which will give me 5. we're going to have 13 minus 9, which is going to give me 4, and then we're going to have 5 minus 8, which is going to give me now minus 3. So what we want to do is show that that angle now is going to be 120. So in general, we can say A dot B will be equal to the mod of A multiplied by the mod of B multiplied by cos theta. Now, the cosine of 120 degrees is going to be minus 1/2. So what we're trying to do is essentially show now that the angle is going to give us now this cosine of minus 1/2. So let's go ahead and do this. What we can say then is A dotted with B divided by the modulus of each will give us now cos theta. So let's put that there. So cos theta, and again, try and make this a little neater than I'm doing. So we're going to have 0, we're going to have minus 7, we're going to have minus 1. Then we're going to have now 5, 4, and minus 3 over the square root now of 0. Then we're going to have minus 7 squared plus now minus 1 squared. And then we're going to multiply this now by the square root of 5 squared. So let's write this out. 5 squared plus 4 squared plus minus 3 squared. So we're going to have now in the numerator, I'll write this just here, we're going to have 0, we're going to have now minus, so writing this out, we're going to have minus 28 plus 3, and then in the denominator, we're going to have now, this is going to give me 49 and 1, so that's going to be root 50, and then we're going to multiply that by 25, 16 and 9, that's going to be root 50. So what we've got now is minus 25. If you've got the root of 50 times the root of 50, that's going to give me 50. That's cos theta. And we can say now minus 1/2 is equal to cos theta. Therefore now 120 degrees. So all we have to do is show using now the dot product that the angle between these two vectors, we've got AP. And again, state that clearly in your working. Okay, let's go ahead and move on. We're told the point B lies on L and AP, BP dash forms a kite as shown in figure 3. The area of a kite is 50 root 3. In part D, we're asked to find the position vector of the point B. Okay, let's now move on. I'm going to move on to a fresh page so we can work with this. If I look at what I'm going to do, and let's just go across one. I'm going to find now, I know that I've got P and P dashed. So what I'm going to consider is the area of a kite. The area of a kite is the base times by the height divided by 2. So one way that we could look at this now is to take this height just here, which is P and P dashed. So if we can get that vector, we'll consider now AB to be the length, and we will just use basic area properties. So what we're going to say then is P and then P dashed. Let's look at that vector right there. So we've seen this now in the previous question. So we got this just here. So we got P and P dashed. So if I wanted to write this out, and we'll use the information just here, let's do that. Let's go ahead. We've got now P, and then we'll say P dashed. So we're going to now subtract away P from P dashed. So if I do 2 minus 2 minus minus 7, that's going to give me 5. We've got now 13 minus the 2, which is going to give me 11. And then we've got now 5 minus the 7, which is going to give me minus 2. So we've got 5, 11, minus 2. So let's go ahead and write that. Let's do that. 5, 11, and minus 2. So 5, 11, and minus 2. So we can say now that the modulus of P dashed, and let's just put this in here, will be the square root now of 25. Then we're going to have plus 121 plus now 4. So that's going to give me now a total of the root of 150. So we can say PP dashed is going to be equal to the root of 150. And we can do a bit of simplifying with this. That's 6 times by 25. So let's write this here. PP dashed is going to be equal now to 6 lots of 25. So we could write this now as 5 root 6. So that's what we have here. So if we consider now, what we've got is this height. That's the height, PP dashed. So this is one way that you could do this question. I can think of a couple of alternatives, but we'll go with this one. That's that distance right there. So what we've got then is the following. We know that the area, so let's just write this here. So let's put area of kite. The area of a kite is going to be 1/2, and then we're going to have base times by height. So 1/2 base times height. So we can say 1/2 multiplied now, I'm just putting this here, 1/2, and then we'll have now this vector, the modulus of AB, so let's put that on, and then if we now multiply this by this height right here, so we're going to have multiplied by 5, and then we're going to have √6, so let's put 5√6, that will be now equal to the area, which is going to be 50, so we've got 50√3. So that gives us what we want, and again I think the calculation could be a little slicker than that, but if we rewrite this, let's go ahead, let's write AB. So what are we going to have here? I'm going to multiply both sides and then divide through. So what are we going to have? I'll do this step by step, such that I don't make mistakes. So we've got 100√3, and then I'm just going to write this now here. So I multiplied both sides, and then I'm going to write this as 5, and then I'm going to write this as √3, and then I'm going to have now √2. Because I got this √6 here, I'm going to just write it here so I can cancel this. So just doing this gradually, remember it's non-calculator, we've got 20 over √2. So 20, √3 is going to cancel. So rationalising, we can say that AB is going to be equal now to, if I rationalise this, this is going to give me now 10√2. So that gives me AB. So if we now consider AB, now I've got this direction vector here. If we look at the direction vector, let's just look at this direction vector. So let's just call this D. Let's look at the modulus of D. The modulus of D is going to be now 25 plus now the 9 plus 16. So the modulus of the direction vector is going to be on here. That's going to be 50, which is going to give me 5√2. So if we consider now, I've found that AB is going to give me 10√2, then all I need to do essentially here, we can say, therefore, and I'm going to place this down here, T is going to be equal to 2. So using the value of T in here, then I can locate now on this line the position vector of B. It's on this line, and we know that we can find any point on that line. So let's go ahead and do that. So let's just plug this in. So T is going to be equal to 2. So R is going to be now 13. We're going to have -3. We're going to have -8. Then we're going to have plus 2 lots of that. So that's going to give me now -10. We're going to have 6. And we're going to have 8. So let's go ahead now and place that on. That's going to give me 3, 3. And then we're going to have 0. So let's put B just here. And that point's just there. So we've got now 3, 3 and 0, and that's one way that we could do it. So let's just put this one back on. So we've got -7, 9 and 8. So all I've done is consider now the area of this kite and just work that out from there. Okay, we now need to show that angle BPA is 90 degrees. So we want this angle just here. So let's go ahead now, and we've got the point P. Let's just put P here. So let's do P. We've got -7, 2 and 7. So if we consider now, let's just get PA. So if we got PA and then we'll look at PB. If we got PA and PB, we can say PA now, if we do the dot product of PA and PB, this will be equal to 0 if perpendicular. So let's get now a vector PA. So that's going to be A minus P. So let's just put this here, PA. We're going to have now the following. In fact, we already have this from the last part because we've already worked this out, but again, it's no big issue to do that. So let's go ahead and do that. So we're going to have 0, we're going to have now -7, and then we're going to have -1. If we consider now PB, let's do PB. We've got now PB, and we'll have PB, so that's going to be B minus P, so that will be 10. Then we're going to have 1, and we're going to have now on here, we're going to have, what's that going to be, -7. So let's just write these out neatly. We've got PA, so PA is going to be now 0, -7, -1. We've got PB, and that's going to be now the 10, and then we've got now the 1, and then we've got the -7. So if we dot these now, we can just show dotting them. So it's stating now, if we just dot these, we're going to have 0, we're going to have -7, we're going to have -1. If we dot this now with 10, 1, -7, what's that going to give me now? Let's just go ahead and do that. So we're going to have now 0, we're going to have -7, and we're going to have +7. Therefore, we can say that will be equal to 0 and it's going to be perpendicular. So that's all we've done. Nice and straightforward from there. As you can see, we're still clogged up with working after working. And this really, if you're putting together one of these questions, don't follow what I'm doing in terms of being all over the place with this working. But the method you can, of course, follow. Okay, we're now told the circle C passes through the points A, P, P' and B. In part F, we need to find the position vector of the centre of C. Okay, so let's use some basic circle theorem here. Let's see if I can get a circle, see if this is going to... Right, okay, I'll do it down here. So what we've got then, let's just draw this. We've got now a right angle and we've got a semicircle. So what I'm going to have then is the following. I'm going to put a diameter across here, and essentially all I'm going to do now is call AB the diameter. So we know that if this is going to be a 90-degree right angle, then we've got this point P. Let's put that on. So this is going to be P, this is going to be A, and then this is going to be B. So all I've got now, I've got my 90 degree. We've just shown now that this angle right here, BPA, is 90 degrees. Therefore, what we can say, we can state now that AB is a diameter. So let's put this on. So if we consider now A and B, so we've got the position vector of A and the position vector of B. We're simply going to find now the midpoint. So we can say the centre, so writing this down, centre is now midpoint. So midpoint of AB. Okay, let's just get these. So we've got minus 7, 9, and then we've got the 8. So minus 7, 9, 8. Minus 7, 9, 8. And then what do we have for B? 3, 3, 0. So what we're going to have now, if we add these together and divide by 2, we can say now centre, we want the position vector, we're going to have now the following. So if I add these, and you might want to show this, I'm just going to go straight ahead and do it. That's going to give me minus 4. Minus 4 divided by 2 is minus 2. If I add these, that's 12 divided by 2, that'll give me 6. If I add those, divide by 2, that gives me 4. Not 2, 4, that's what I want to write. So we can say minus 2i plus 6j plus 4k is going to be now the centre of that circle, and that's just using circle theorem. So there we go, lots of work on that question. Hopefully it's made sense. Hopefully my workings haven't detracted from what I've been doing too much. But with all of these questions, a good understanding of basic vectors is always required. Some understanding of basic geometry and things like area and the way in which you can manipulate these things. And then a bit of sidestepping. So that's one way that you could do that question. As stated earlier, there are lots of different approaches, but that will give you one particular approach.